chemistry change, there were large variations in climate, there's active geology, there's impacts, so there's always been forces for life to adapt, and life has adapted on our planet, and the adaptability is dizzying. A huge array of diversity has appeared in life on our planet over geologic time. Some of that is captured in this concept called of extremophiles. Extremophiles are lovers of extreme conditions, rock climbers or cave divers or high wave surfers, right? You're an extremophile. Some of these simple extremophiles occupy enormous ranges of temperature, acidity, salinity, radiation, pressure. Okay? The greatest range is exhibited by the simple single-celled organisms, the prokaryotes, a huge range also by the eukaryotes that show wide ranges. Complex life shows wide ranges as well. High temperatures, low temperatures, battery acid to very alkali waters, fresh water to extremely salty water. No matter where you go on the Earth, you can find organisms that are occupying these niches. The battery acid ones freak me out. What are they doing in there? Right? But they're perfectly happy. They've adapted to these environments. So life can adapt to extreme environments: permafrost, hot springs, battery acid, salty lakes, deep under the ocean, deep under the ground. Even out in space, there have been examples of organisms that can be sort of revived even after being out in the vacuum of space. Question?
Yes, I remember, was it in 2011 when they came out with the monolith study about some extremophiles? That may be one of the organic molecules.
In a very, was it arsenic-rich environment?
Right, it was replaced, was it phosphorus? Mm-hmm. Is that something that...
There's a huge debate about that result.
Huge debate, okay.
That result is not widely accepted
okay.
in the scientific community, so it's a hypothesis that's been put out there. But if it does get confirmed, then it says that, yeah, there are ways that life can adapt, even at the periodic table level, to replace some atoms with others that will make it more able to survive in harsh environments. So maybe it should be surprising, but that specific result hasn't been confirmed.
Okay, yeah. So then I guess we haven't changed our approach in putting like sensors or, for example, rovers to look out for those type of changes yet?
Not yet. Okay. Nope, and I'll talk about those in a moment.
Okay.
Question?
Yeah, so are extremophiles, are they generally or almost always microorganisms, or are there any more like multicellular?
So some of the prokaryotes, which are multicellular organisms, can survive eukaryotes can survive in extreme conditions. But the range, the more complex life forms have a narrower range of extreme conditions than simple life forms. Okay, so where are we going to look if we're going to look out elsewhere out there? This huge range of diversity and ruggedness of life on Earth has only recently been recognized, the last few decades. So the idea of simple life beyond Earth is not as crazy as it used to be, and it used to be thought of as crazy. But maybe it's not so crazy after all. So you can make a short list of places to look, places where the conditions might be right. Talk about Mars, Europa, big moon around Jupiter, Titan, big moon around Saturn, Enceladus, tiny moon around Saturn. What's that doing on the list? Talk about these places. That's the work, there we go. And there may be more that we could add as we're constantly continuing to look and discover the worlds around us. So just fly through some of the evidence for life on Mars. Mars has clues that its climate may once have been very different, and that there's still a substantial inventory of water, liquid water, water ice, water vapor at or near the surface, and that there were abundant sources of energy, volcanoes, impact, maybe geothermal, liquid water, energy sources, organic molecules. That's one thing we don't know much about, but remember there's a rain, asteroids and comets, maybe it's supplying organic molecules everywhere. The ingredients, the requirements for life as we know it seem to be there. Mars has a lot of similarities to the Earth, tilted on its axis so it has seasons, it has polar caps, had active volcanoes, active tectonics, impact cratering, magnetic field, maybe a molten interior long time ago, wind and weather.